Hi, my name is Riley Innes, and this is a pre-recorded presentation for the 2021 meeting of the Society for Mathematical Psychology. This work is some preliminary joint modelling work on the distraction task in collaboration with Juanita Todd and Scott Brown from the University of Newcastle. The distraction task is a widely used task for studying attention, typically used in EEG studies and in the study of schizophrenia. Typically, participants listen to a sequence of tones whilst undergoing the EEG scan. In our study, participants had to indicate whether the tone was short or long in length. In the sequence of tones, there are standard pitch tones, which are common, and deviant tones, which are less common, and can either be low frequency tones or extra high frequency tones. These deviant tones produce a unique EEG mismatch compared to the standard tones. The difference between the standard and deviant ERP waveforms is known as mismatch negativity. This is an auditory ERP that is thought to reflect components of attention, such as sensory memory. Patients with schizophrenia show a distinct lack of MMN from the distraction task, as you can see here. In the current experiment, we aim to model the distraction task with a linear ballistic accumulator of decision making. In the model, there were several commonly observed effects to account for, the first being a slowdown after deviant trials. Here we included a post-deviant effect of the LBA threshold parameter for biased responding. Secondly, it was hypothesized that the effects of the deviance would be observed in the drift rate. We fit several free models to the task, but decided to extend this further to see whether the ERP components were related to decision-making processes. For this model, we used two methods, a mean method where we took the mean of ERP components for each trial type, and the trial-wise method where we used the individual trial-by-trial ERPs, which were standardized. All ERPs came from one location, FZ. For both of these methods, the N1, N2, and P3 amplitudes were weighted and added to the mean drift rate for correct response accumulators, or subtracted from the mean drift rate for error response accumulators. This equation shows how correct and error drift rates were estimated. Here, the coefficient shows how much each component contributes to the drift rate in the model. We then estimated these two models and a null model using the PMWG-R package. Summarizing the results briefly, the null model included the threshold change for post-deviant trials. In these graphs, I'm showing RTs first and then accuracy second across trial types, reading left to right, low deviant, high deviant, then the standards after deviant, the standards before deviance, and standard trials on the far right. There were two difficulty conditions as seen here, with left being easy and right being hard. There was staircase to different accuracy levels. Here we can see that for RTs, the null model does an okay job in both the easy and hard conditions, except for deviant trials as shown on the left. For accuracy, as expected, there is no difference across conditions. In the mean ERP model, the model captures a lot of the variance in RTs in the easy condition, but less so in the hard condition, especially in the deviant trials. A trend which is similar for accuracy. In the easy condition though, the model does capture a lot of variance. This is similar for the trial-wise ERP model, for both RT and accuracy. However, less variance is captured in comparison to the null model in accuracy. Ultimately, these results show a sound start to this modelling project. First, it is evident that there is a bias towards short tone responses. Secondly, surprisingly, P3 showed a higher coefficient than N1 or N2, which we expected to be driving the evidence accumulation process. However, the coefficient models do capture some of the variance seen in the deviant condition, which is promising for future work. We could also investigate a range of other effects before considering data from a schizophrenia patient group. Thank you.